Welcome everyone to the session, and we will start now. Welcome, Dr. Mufti, and welcome everyone again to the second session for today. So I want to introduce myself first. My name is Feroz Mustafa. I'm a PhD researcher, and I will be the host and the moderator for the second session from ICICT 2022 for today. So dear authors and invited guests, welcome to this technical session 5B. On behalf of Global Knowledge Research Foundation, it's a great pleasure to me to welcome you to the 7th International Congress of Information and Communication throughout Zoom. As you are aware, we need to move online due to some restrictions after the pandemic. However, we highly appreciate joining us through the online platform, and we hope that you and your families are safe and in a protected time. We hope that you will enjoy the rest of the second day of the conference. As a quick note, that you will have 10 to 12 minutes for presentation. The last 3 minutes would be for the questions and answer for the participants. If you have any question, you can send it directly to the chat and I will share it on your behalf if you don't mind. And otherwise, please stay muted to make sure that there is no background noise. Before we start with this session, I would love to introduce the chair, Dr. Mufti Muhammad. He's a senior lecturer in computer science at the School of Business and Technology. Dr. Muhammad has a master's degree in data analysis for business and data start and online MBA course. He's also a member of NTU Distance Learning Governance, Operating and Screen Community, as well as International Mobility. He's expert and well experienced in the blended learning online system in higher education, and his experience extended for online postgraduate level 7 big data projects and many other areas. Also, he's a member in IEEE World Congress in the UK. So I welcome Doctor, and it's my pleasure to be your moderator in this session. All the best for the participants. So moving forward, we will go to the first presenter with us. Yeah, we will go to the first presenter with us for today, who would present a paper titled as Weight-Based Dynamic Hybrid Recommendation System for Web Applications. It would be presented by Mr. Ru on behalf of the co-authors. So it's over to you, sir. You can share your screen. I will stop sharing from my side.
Okay, thank you, and good morning to you all. I will share the screen. Okay, I think you're seeing the presentation.
Yeah, I can see the presentation and we can hear you clearly. All the best. Go ahead, please.
Okay, thank you. So I'm here to present the work of Margarita. She was a master student with us in Research Center in Digital Services. She has some technical issues, so she will, I don't know if she will be able to answer the questions, or I will provide the email if you have any questions at the end of the presentation. So the paper is a weight-based dynamic hybrid recommendation system that's applied at web application content. And in this work, we collect information offline datasets from various unstructured sources related to films. We prepare data for analysis. We clean, normalize, and combine data. Also, we use content-based data extraction algorithms that allow to make predictions based on textual information from already rated films, as well as algorithms based on collaborative techniques to recommend items rated by users with similar tastes or interests. These combined techniques will allow hybrid learning. Moreover, it will allow the user to select the topics of interest of his or her preference and thus overcome the lack of information about the user at the start of the application, the cold start problem. Moreover, we dynamically learn the interest of the user as he interacts with web applications using computer learning, as well known as machine learning also. Moreover, we recommend personalized and relevant information to each user based on their preferences, taking advantage of the knowledge produced, as well as the feedback. At the end, we identify the ratings of the items. The user will be able to understand the ratings and positioning of the items assigned to him and in relation to the ratings assigned by others. Our contributions are a hybrid recommender system for movie recommendations. It allows testing and evaluating recommendation algorithms based on CBF, CF in memory, and an HF, allowing an identified user to obtain a good recommendation of films not yet evaluated. Combination of CBF techniques based on the TF-EDF methodology with the CF techniques where the KNN methodology was applied. Weights are dynamically assigned to each technique, giving rise to a weight AF system. The weights of each technique are obtained based on the number of classifications performed by an active user. The recommended system intends to choose for an active user that maximizes the user's usefulness. Forecast is a numeric value that expresses the source of the assessment of the item for the active user. The techniques used in the recommendation system are the hybrid filtering techniques, which are based on content-based filtering and user profile, and user-based collaborative filtering. Another natural language processing technique here, list of 3 movies that match in the title items the search sentence. Application of the proximate pattern identification technique called fuzzy string matching of the movie-lens movie dataset. A match ratio of 35% was used since the higher values, sometimes no matches were obtained, depending on the length of the sentence pattern. The content-based filtering produces a similarity matrix, a square matrix, with the similarity between items U and V. The cosine similarity value between 0 and 1, and the higher, the more similar. Pearson's correlation coefficients between -1 negative correlation to 1 a positive correlation and 0 without correlation. Euclidean distance also greater than 0, and the smaller, the more similar. To find similar items for a given film, simply sort the column of the row of the similarity matrix corresponding to a particular film in descending order, constituting the top N type recommendation. The content-based filtering and user profile, they are based on film similarity, taking into account only active user ratings. It assumes the creation of items and user profiles. Users prefer genres based on the genres or films classified by the item are defined as user item profiles, TDF, EDF normalized vectors for movie genres. User profile is defined as a TDF, EDF normalized vector of user genre and preferences. The vector of similarities between user items, internal products between the user genre preferences vector and each genre vector of the films is obtained. The top N recommendation is obtained from the vector of similarities with descending order, removing the films already classified. Moreover, to get the ranking predictions for an item not yet ranked are used the user similarities with the items already rated in the ratings assigned to those items. The user-based collaborative filtering, the process is divided into several stages. First, we calculate the similarities between users, next the neighborhood determination for users, and then the prediction of ratings for items not yet rated by an active user. The offline movie dataset is used to calculate the forecasts combined with the ratings already assigned by the users of the system, and a matrix of user items rating is created with the ratings adjusts user features data frame in which each rating is subtracted from the user's average. Since there are adjust ratings with the value of 0, filling in the adjust ratings that have not yet been classified, defined as none values, can be done in 2 ways. Determining the average of the adjust user ratings, that is, average of the lines of the matrix of average of the items adjusted ratings, which means that the average of the matrix columns. Both approaches were implemented to be experimentally compared. To calculate the similarity between users, using the cosine similarity, the user item matrix is used. As the average rating of the user was subtracted from ratings before calculation, the cosine similarity, this measure is equivalent to the Pearson correlation, where when user rates the same items. The similarity matrix is the basis for creating the active user's TNN neighborhoods. At the level of the user-based collaborative filtering, to calculate the prediction of the rating of the active user for an item not yet related by it, the equation is applied after selecting the adjust rating and the similarities, which are the correlations between users of the key nearest neighbor. In equation, I refers or corresponds to the item for which we want to calculate the forecast for user U who was not yet rated this item, with R being the rating assigned by the user V to the item I, and V represents the neighborhood of user U. This average is weighted by the sum of the absolute values of similarity between users. Subtracting the rating from the average of the users who performed allows to compensate for differences between users in the use of the rating scale. For the top N recommendations, all films not yet rated by the active user, but which have been rated by the neighbors, are selected, constituting the list of films to consider. For this, the classification forecasts are calculated according to the previous paragraph, ordered in descending order of forecast, and obtain the first N elements and respective forecasts. By using this methodology, the collaborative filtering cold start problem is solved, combining the collaborative and content data of the items in a way that users who have little ratings or are new in the system can have recommendation of interest, and even if the recommendations are not accurate and unexpected. The implementation carried out proceeded to combine the CF technique with the CBF, where weights were assigned to each technique, giving rise to a weighted HF system. This allows to obtain the top N uses preferred by an identified user, including the rating predictions to be assigned. An implementation adapted from the dynamic weight technique was carried out, who combines in a linear way the results of the described personality recommendation techniques. And in weighted hybrid systems, the outputs of several recommended systems are combined using a set of weights. The ideal is to weight the various systems differently in order to give greater importance to the most accurate systems. In the implementation carried out, the following linear combination equation was used to calculate the prediction score. This one. Assessing the quality of recommendation algorithms basically consists on evaluating the degree of acceptance of recommendations, quantifying the number of times users accept or reject recommended systems. Statistical accuracy metrics evaluate the accuracy.
Sorry for interrupting you, but we have 2 minutes more. I'm sorry. 2 minutes more. I'm sorry for interrupting.
I'm going to finish. Thank you. The accuracy of filtering technique by comparing the predicted ratings directly to the user's actual rating. The recommender system generates a ranking prediction given by R for a user per item. RMSE, the root mean square error, the lower the value of the RMSE, the higher the quality of the classification predicted algorithm, and the mean absolute error measures the average difference between predicted ratings and actual ratings. The lower the mean absolute error, the better the quality of the algorithm in predicting classifications. So what we have here is that user profiles are created based on a classification they have made and which are contained in the training dataset. The forecast depends on the ratings already made by the active user. So regardless of the music to be classified, the forecast is similar. The more convenient value for training variable X equal 0.28, since it is one that for RMC and MI has the lowest value and better precision. Implementations were carried out to replace the NaN values. And in this case, what we have is that the mean absolute error 0.9 in implementation on the average user versus the MI 0.67 in the implementation based on the item mean. Bearing in mind the datasets used for the tests, the implementation techniques always consider a confidence factor of 0.9 for the CF prediction. All users rated at least 14 items. Thus, with the exception of the tests carried out with 2 neighbors, the results show that the HF implementation follows the CF implementation. With 2 neighbors, the CBF implementation contributes to the improvement of the recommendations. These results confirm that the recommended decision CBF are good at finding similar items and do not need much information about the ratings of the active user and can be used when there is not yet a user profile with many preferences. It is thus a reality that the cold start problem can overcome with the contribution of the CBF technique. However, in the dataset, this evidence in the HF implementation was down to the experience of less than 5 neighbors. As a conclusion, the objectives outlined correspond to the study of the development of recommender systems with techniques based on content or collaborative and in their combination. A prototype of a website was created with special focus on the backend for recommending movies. It allows to be an intermediary for information made available online by TMDB and to make non-personalized and personalized recommendations for registered users from Movieland's latest dataset. Sorry. The metrics used were the mean absolute error and the root mean square error to validate the consistency of the results. It was found that the Movieland's datasets used allowed us to conclude that the trends already presented in similar studies, but due to their size, they may not have completely clarified some conditions of application of the techniques. Specifically, based on the datasets used, since users always rated at least 20 films, the major contribution from CBF was identified for the hybrid recommendation unless 2 neighbors were considered. From the tests carried out on the prototype and the validation results, the recommendations obtained proved to be interesting from the empirical point of view and valid with root mean square error lower than 0.95 and mean absolute error lower than 0.73 in all implemented techniques. Thank you for listening to this presentation.
Thank you very much, Dr. Rui Pedro. I think that it's a nice work, and given that we are already over time, even then, allow me to ask a couple of questions, which is very much traditional to any recommender system, because, well, I saw that you have addressed the cold start problem, which is very good, because that is one of the challenging issues in any recommender system. However, well, how did you handle the problem of sparsity? Because, well, we know that the recommender system, the data that you consider based on the web contents are not always complete. So there is a lot of sparsity. So is your system robust enough to handle the sparsity in the system?
Well, I don't know if, stop sharing, sorry. I don't know if Margarita can answer. She's there, but she has some technical issues. I don't know if she can answer the questions you have. However, I will provide her email if you have questions, if she can answer them. I will put it in the.
No worries. Yeah. Okay. So that was just a curiosity, because, well, a recommender system has to be robust in terms of a number of different factors, and one of the factors is actually the sparsity. But, well, that's fine. It's understandable. So
not answer, no.
Yeah. So Feroz, so thank you very much for your presentation.
No, thank you.
Let's move to the second one, please, Feroz.
Yeah. Thank you. So the next, the following presentation is actually from yesterday due to technical issues. So it's over to you, Yusrani, if you wanted to go directly to your presentation. Could you please just share your screen? No?
Yes.
Yeah. Please share your screen, and we are all with you. All the best.
Can you see my slides?
Yeah, we can see the slides and hear you clearly. All the best. Go ahead with your presentation, please.
Yes. Good afternoon, everyone. I'd like to thank you for giving me the chance to speak here today. My name is Yoshinori Wakatake from Ritsumeikan University. The subject of my presentation is calculation of user awareness by text features to improve specification quality. First of all, I'd like to talk about the introduction. In software development, it is important to ensure the quality of the specifications and design documents in the upstream process because they affect the quality of the deliverables in the downstream process. However, many defects found after release are caused because of poor test specifications. If necessary test items are missing, the software may be released with insufficient functionality. In addition, when testing, it is necessary to envision what end users expect or how they behave in specific contexts. In this study, we call all such behaviors context. This study defines user awareness of writers as their envisioning concrete contexts in which end users put the software into use when the test specification is written for a given software specification. Next, I'd like to talk about the hypothesis and the purpose of this study. The study assumes that test specifications written with user awareness exceed others in quality. The study analyzes text information to see if there is a difference in text features between writers who have user awareness and those who lack. The purpose of this study is to estimate the degree of user awareness of writers through the analysis of their text information. Identification of text features for each quality of test specification leads to a successful classification of test specifications. The proposed method enables us to automatically detect poor quality test specifications, which has said to be a big hurdle for cost reduction in software development. First, this shows an overview of the method. The proposed method focuses on the writer's text information of both specifications. Using the text information, the method classifies test specifications from the viewpoint of whether the test specification writer has user awareness. Next, I'd like to talk about the hypothesis of text information and advantages of using text information. Based on the many examples of test specifications with user awareness and without user awareness obtained in this experiment, we will consider the text features. The details of this experiment will be explained later. Test specifications of each quality level are manually examining to figure out their text features. The results of the examination revealed two features of correspondence and word types between software specifications and test specifications. Therefore, the following two types of text features will be corrected. If results supporting these hypotheses can be obtained, the degree of user awareness can be quickly determined from text features, which leads to the detection of pairs that are prone to omissions. Therefore, it is possible to immediately detect specifications of poor quality to determine the user awareness of new specifications using text mining without limiting to specific software. I'd like to explain in detail about the degree of intersection and degree of word embodiment. First, I'd like to talk about the degree of intersection. The user awareness increases the degree of intersection of sentence correspondence between software specifications and test specifications. Naturally, the number of sentences in the test specification is larger. So there are many correspondences from software specifications to test specifications. Suppose a test item refers to multiple specifications items of a software specification. It means that test item checks specification items mutually related in the software specification. In other words, a large degree of intersection means that the test item checks multiple contexts of the software specification. However, test comprehensiveness cannot be expressed only by the degree of intersection. The degree of word embodiment should be calculated to consider the comprehensiveness. Next, I'd like to talk about the degree of word embodiment. The user awareness increases the degree of word embodiment. The higher the degree of word embodiment, the more words appear in the test specification than in the software specification. Naturally, the software specifications only describe the context of the correct case. If writers create test items with user awareness, writers will write all incorrect contexts that were not written in the software specifications, expanding the correct context. the word set is far larger in the test specifications than software specifications. Most of the words used in the software specifications should be used in the test specifications. Therefore, the degree of word embodiment is used to evaluate the degree of user awareness. Next, I'd like to talk about experiment. The hypotheses on text information are verified through experiments. The purpose of this experiment is the following. The subjects are 13 university students, including graduated and undergraduate students. All of them are new to creating test specifications. They made test specifications from the software specifications. This shows the software specification and test specification used in this experiment. The software specification used in this experiment is the Othello game development, which is an assignment all subjects experienced. The following 3 items will be added: initial display, stone placement, and pincer attack for a total of 8 pages. Next, I'd like to talk about the method of analyzing. In this experiment, the test specifications were evaluated by a company employee who is a professional specification writer. Based on the idea that the specification with user awareness is a good specification, the employee evaluated the specifications from the viewpoint of whether they have user awareness. In this experiment, 1, 2, 3, and 4 belong to the bad group, while 5 the good group. Namely, the good group consists of test specifications with user awareness, for the bad group ones without user. Then, correlation and theta pros between the text features and the test specification evaluation are calculated. First, visualize the relationship between the text features. These figures show the scatter plots as degree of intersection and degree of word embodiment for initial display, stone placement, and pincer attack, respectively. Next, to suggest that the correlation is not a pseudo-correlation, a random forest model is constructed to estimate the degree of user awareness from the degree of intersection and the degree of word embodiment. Here, four-fold cross-validation is applied in order to attain the accuracy. The accuracy is 0.76. Therefore, it is suggested that these correlations are not pseudo-correlations. This table shows the correlation coefficient between each text feature and the test specification evaluation. First, I'd like to talk about the degree of intersection. In this table, the correlation between the degree of intersection and the test specification evaluation was high for stone placement and pincer attack, but no correlation was found for initial display. The reason may be that the description of the initial display is simple, and therefore the evaluation was high even if the requirements of the software specification and the test items were described in a one-to-one manner. On the other hand, the descriptions of stone placement and pincer attack are the various rules and patterns of the Othello game. Therefore, we can conclude the key to writing test items with user awareness is how to be specific and the context that is not written in the description. Next, I'd like to talk about the degree of word embodiment. The degree of word embodiment shows the same trend as the degree of intersection. In summary, the degree of intersection and the degree of word embodiment were found to be important indexes for evaluating the user awareness, although the content itself needs to be considered. Finally, I'd like to finish my presentation by summarizing our study. We proposed a method to estimate the degree of user awareness using text information when writing test specifications from software specifications. The study paid special attention to the degree of intersection and the degree of word embodiment. An experiment reveals the method can estimate the user awareness of the writer with high accuracy. The degree of intersection and the degree of word embodiment showed a positive and significant correlation with user awareness. Since it is possible to quickly and accurately detect poor quality test specifications, which are said to be a big hurdle, we can achieve the development of high-quality software at a low cost. In the future, it will be necessary to verify specifications for other types of software to conduct analysis that considers the content of the text. Thank you for your attention. I will now answer any questions you have about this study. Please speak slowly and clearly. Thank you.
Yeah, thank you very much for your presentation. Unfortunately, well, we are running out of time here. We do not actually, this presentation was not anticipated to be here in this particular session. So we are not going to have a question and answer for this paper. If any of the attendees are having questions, I would request them to write directly to the presenter for their questions. Fairuz, can you move to the next presentation, please?
Thank you.
Yeah, for sure. Thank you for the time and the presentation. So moving forward, now we have the next paper titled as an incorporate solution to support elder people in studying their family's surroundings, presented by Mr. Dominic on behalf of the co-authors. It's over to you, Mr. Dominic, and sorry for letting you wait. Thank you.
No problem. Hello, everyone. Nice to see you or hear you. I will keep my camera shut because I want the sound to be
totally
good.
Fine. Yeah, it's totally fine.
Okay.
I just need to share the screen. Okay. Yeah, we can hear you and see the slides. Go ahead with your presentation.
Great.
All the best.
Thank you. So I will present a paper related to the SAFE system, which is an incorporated solution to support elder people in staying in their familiar surroundings. It's being developed under the AAL program, so active ambient living. The SAFE system purpose is to keep elder people autonomous for as long as possible inside their homes. Also to create a feeling of safety inside their habitat. This solution was developed using co-creation and co-design sessions. So we had a lot of meetings with elderly people and asked them what they think is most important for their safety. And three categories emerged. One for safety, which again, it's about having a way of announcing caregivers, being informal or formal, of emergencies, so an SOS signal. Location tracking, because some of the elderly could have mild cognitive problems, so we have to know where they are at all times. Also, fall detection, which is very important for them because they had situation in which they fell down and couldn't announce anyone. Also, ambient sensors were included just to monitor the ambient like temperature or floods, so to protect against floods and fires. Also, a well-being part it's included. It's mostly related to getting information about their health using some biometric sensors, and also utility like schedule notification reminders so they don't forget to take their medicine, for example. This is the general overview of the system. So we have the elderly habitat. They are equipped with a smartwatch that acts also as a sensor, wearable sensors. We have an e-health device, which is the well-being part, so getting biometric data from them. Also, they have access to a web application that it's hosted inside the Safe Cloud. Also, we have other actors like researchers, administrators, and caregivers. They have also interfaces, user interfaces for the system. there are more modules inside the cloud application, the Save cloud application. We have the user interfaces. We have a machine learning inference layer, but I will not discuss about it today. The security center for measuring security, getting information from sensors, and collecting the data into a centralized database. The connection is done by Wi-Fi, or the watch can be connected through an eSIM to the GSM network and getting the internet from there. The safe solution for the elderly includes the wearable sensor, the smartwatch, which has a customized watch face and an configuration application. Also, a kit of sensors for fire, flood, presence, and contact. All it's integrated inside the safe system using ESP32 microcontroller kit, and access to the application where the user can also self-register. So it's a quite easy system to get access to. And also some other devices, the manual, and of course, the caregiver support. The caregivers in the system have access to a web application, user manual, and remote technical support. And the administrator have this application, which is a web-based one, Save Admin Center. This is the kit that all the users receive. We developed especially for this kind of kit a safe sensor adapter, which actually reads the data collected by the central hub and feed it into our system, into the cloud. The safe system is built using the latest technologies and runs in a cloud environment in a context infrastructure as a service. It takes advantage of containerization because the architecture is based on the microservices, which of course offers a lot of advantages, scalability, less overhead, greater efficiency in general. The technologies, this is the stack for the Save Cloud application. It's based on Java technologies, the Spring Boot framework. The user interfaces are based on Angular, connecting to REST APIs provided by the Spring Boot application, and the Bootstrap for having a responsive interface. The smartwatch applications are implemented as a Tizen web application using HTML, JS, and cascading style sheets. And everything runs either on the virtualized machines or on Docker, so as containers. The data collecting system offers REST APIs over HTTPS, so the security it's achieved through the public key infrastructure. Data transmitted between all the parts is done using JSON format. For example, for the data collecting system, this is a minimal JSON document. The system device communication model is in this picture, and this is how we solve the problem of having different sensors from different providers, so we can collect them and keep them in a uniform way. So we develop these interface data adapters that intermediates between the device and the data collecting system. The devices usually use the HTTPS protocol, but it's not mandatory. We can use MQTT as well. The data, it's organized in table-based, in a relational database. We use table-based partitioning. Also, just to respect the GDPR, there are no information about the users. Everything are only numbers. so IDs, which can be connected with the users, but it's more difficult. This is a diagram of how the devices are organized. So the device belongs to a safe kit. It has a device type. That means we know in the system how we can display information about that device, and has values that stay inside these partition tables. Going back to the safe
I'm
application.
really sorry, but we have 2 minutes more possible to conclude. Thank you.
Okay, I will say 2 phrases and that's it. Okay, so this is the same web application, the micro services that are included. This is a few screenshots of the Save web application with graphics, with reminders, with caregivers that can see the data of the elderly they care for, the last 10 known position of the user, and the Save Admin Center, which we can see all the data collected by the system and also register devices, kits, users, and so on. This is the application that is an application and the configuration one, and these are the conclusion. I think I gone already through them, so I can stop here. Thank you for your time.
Okay, thank you very much, Dr. Dominic Michera. I think that it's a very nice piece of work, and I actually have some curiosities about this work because of its nature and its practical implications and impact on the currently growing population with elderly. Now, the very first thing that I would like to know that in terms of the data analytics, well, I understand that it's a system which is collecting the data, very nice. It's a multimodal system, so collecting different types of data. So from this data, have you been able to analyze the data and predict the fall?
The prediction of the fall, it's done automatically by the watch. So we actually currently using the Samsung's detection of the fall. Of course, we intend to do that also by ourselves by collecting the data and provide, but it's a work in progress for now.
Okay, excellent. And in terms of, let's say, their location and whether they are in need of any help or anything as such, do you have any indication of the data analytics pipeline that how you are going to predict the movement of the elderly people in their surrounding as well? So do you or is the system capable of identifying activities which are even routinely done?
We are working now because the machine learning module is in work, so it was not presented, but we are working on because usually when people get disoriented, it begins to go in circles, and we are working on detecting these circles and then trigger an event for the caregiver that maybe the user is lost. Also, an easier one that we actually have, it's just we know where the home is, and if they go farther than pre-established distance, then we trigger an alert that maybe the user is lost.
Fantastic. Well, this is something which is fantastic. Well, I would like to invite you to kindly write me an email. Maybe we can discuss about this even further. Yeah.
Okay.
So I'm just going to write my email in the chat. So if you please send me an email, I'll be very much willing to discuss it further. Okay.
Okay, thank you.
Just for the sake of being on time, I would like to thank you for presenting your nice work, and I would request Fairuz to go ahead with the next one, please.
For sure. So thank you for the great presentation again. And now we are moving forward to the next paper titled as real-time pain detection using deep convolutional network for facial expression and motion, presented by Mr. Korambam on behalf of the co-author. So it's over to you, sir.
Hello, everyone. Let me share screen first.
Yeah, please.
Okay.
We can see it. Go ahead with the representation and all the best. Thank you.
Okay. Good afternoon, everyone. My name is Gonpom Bikunkao from Department of Computer Science, Faculty of Science, Chiang Mai University, Thailand. Today I will present you about real-time pain detection using deep CNN for facial expression and motion. Some parts of this presentation is presented by permission from ITB, Internal of ITB Access. Let's talk about agenda first. It consists of 4 parts: introduction, methodology and results, discussion, and finally, conclusion and question and answer. Nowadays in hospitals, especially developing countries, many medical staff like doctors or nurses have to monitoring patients all the time. In some cases, they must take care 7 days per week. It can contribute to strain. Hence, if we create automatic system, it will solve this problem. In the past, patient and care personnel used the self-report technique to measure pain. However, it also have drawbacks, such as precision. After that, the observation rating scale, or ORS, was developed. This is a vital part of this research contribution. Thirdly, and real-time pain detecting techniques is our primary goal, utilizing deep learning. This approach can achieve more state-of-the-art than other classifications, such as SVM or neural network. Secondly, a motion strategy that can help many patient orientation as they switch from side to side. Thirdly, the embarrassing method avoided by models with fewer samples. The advantages of this research are: first, support parents or interested people who use measure pain to their children or themselves before going to see the doctor. Next, reduce the cost of using healthcare services. Next, help medical staff to watch over patients who in some cases require 24-hour monitoring. This research can be divided into 4 phases, namely pre-processing, processing, post-processing, and evaluation of the system. Phase 1, we try to normalize the sequential image from the UNBC and the JAFFE datasets to be the same standard, such as size and lining. The UNBC datasets focus on patients with shoulder pain that have almost 50,000 images with 25 subjects. The Japanese female facial expression, or JAFFE datasets, focus on 7 different stage poses. This includes 6 different basic poses and 1 neutral pose. This picture shows how to plot AM landmark to find action unit or AU and calculate pain. Phase 2. Start with the calculation pain by using action unit or AU. This slide shows the location of AU. We use AU4, AU6, AU7, AU9, AU10, and AU43 to calculate PSPI scale. We use 80% of sequential image for training and 20% for testing. We need for a method for image processing developed by he and all is the foundation of our face recognition architecture. The number 34 refers to the number of layers in the CNN used in our pain detecting algorithm. About our real-time system, we try to more library to improve accuracy and speed. First, David King debrief library, and second is advanced facial recognition. Moreover, our system have two modes of real-time system. First is deep convolutional neural network. Second is histogram of oriented gradient. Our work can classify pain into T category: non-painful, starting to be painful, and painful. You can see in this picture. This is example of our pain detection. The left picture shows no pain cause, whilst the right picture shows indicate pain. And this is another example of our pain detection. Another example that focus on women. And another example. Phase 3, we test and integrate our system and add warning system with sound effect in this step. Phase 4, we invited doctor or experts to evaluate our system. The table presents the evaluation process of our approach utilizing real-time pain detection and motion algorithm. We achieved 99% precision in the results you see in this table. The precision was not right in small batch size, but high in broad batch size. Besides, we can also accomplish the output target in the short input. In the future work, we will try to use optical flow to get the best motion estimation and support every degree of freedom. In summary, at Impulse, we used sequential image from UNBC datasets and JRFE datasets. Next, we processing using deep CNN, and the output we got both level pain and interstitial pain. Conclusion. We believe that deep learning approach, such as 2D facial expression and motion, beats more conventional methods in terms of accuracy and cost. Moreover, we intend to replace motion vector with optical flow and work on 3D plane detection in the future. And this is our team is consists of me, Gonpomikungal, and two of my advisors. It consists of Professor Ekalat Bunchiang and Professor Walapon Bunchiang. Furthermore, we also thank Professor Jean Kim and the Social Ecotech Institute at Konkuk University in Seoul, Korea. And this is our reference in this picture. Thank you for your attention.
Thank you very much for your presentation. Well, it's a nice one. I just have one question. Did you have the opportunity to compare it with other state-of-the-art methods? Because, well, pain detection from facial expression or from images have been quite explored. So when you compared it with other methods, how did it perform, your RCNN method?
Oh, okay. In our journal, we have already compared our method between deep CNN and SVM, and deep CNN is better than SVM because I think it's because hidden layer can help. Yes, can help the process.
Okay, so in terms of the deep CNN, did you use any pre-trained model? I mean, any specific existing models that are available, or was it something that your own custom developed?
Actually, I used Reddit 34. This is our P10 model to help. That's why we not started from the scratch. Yeah.
Okay, so do you have any, let's say, plan to explore a little bit more? For example, there are other models like ResNet and related models, yeah? So there are the VGGNet, ResNet, and all these different pre-trained models, and then compare it with the models that you have, rather than having a comparison with SVM, because I understand that SVM is something which cannot be compared with deep learning models.
Yeah, I see. In the future, I plan to compile our work with the other people that work on deep learning and try to improve our accuracy and performance.
Okay, thank you very much.
Thank you.
So Fairuz, I request you to go to the next one, please.
Yeah, we don't have any question on the chat, so we'll go further to the next presentation by Mr. Kurt on behalf of the co-authors to present the paper Location-Based Service Discovery for Mobile Edge Computing using DNS. It's over to you, sir. All the best in your presentation.
Hello, everybody. I wish you a very nice afternoon today. I'm going to share my screen. I'm going to start my presentation.
Yeah.
Can you see my screen? Is that working?
Yeah. But if possible, could you please make it full screen?
I think it's still trying to load on full screen.
It's handy.
It's a bit hanging.
Yeah, it's fine. It's totally fine.
Oh, looks much better. So thank you for the opportunity to speak here. My topic for today is location-based service discovery for edge computing using DNS. My name is Kurt Howard, and I'm a senior researcher at the Carinthian University of Applied Sciences. And I'm a member of the 5G research group here in Carinthia. Let's dive a bit into the topic and make some clarifications. First of all, we need to discuss briefly about what is edge and fog computing, because those are two terms which evolved in the last couple of years and extend basically the terminology established by cloud computing. Edge computing, so to say, is bringing the computational power closer to the user, so to say. So the application or the service we want to consume is not provided from a server which is very far away from us. Rather, it is hosted somewhere close in the proximity of the consuming device, which will drastically reduce the latency for the consumer to access the service. There are, in general, in fog and edge computing, there are a couple of characteristics which are rather important to talk about service discovery. The first of all is the geographical distribution. So we have a much finer network of how devices are getting distributed. We have one big benefit, which is the contextual location awareness of the devices. So if you have a smartphone, the device knows where it is, it knows about its location. We have new networks which provide us low latency, especially when we talk about 5G, we can use its capabilities there. We have, in general, a very heterogeneous network from the consumer side, but also from the servers which we will find in the edge. We have a predominance of wireless access in those networks, and of course we have fully support for mobilities. And this we have out of the box order, we see a couple of challenges. And the first one, which is the most addressed one, is security. The second one is that we have this heterogeneity. And the third one, due to the fact that we talk a lot about mobile devices, we have energy management concerns. So what do we want to achieve? We're talking here about service discovery. So we are expecting we have a couple of edge servers, so to say, near on the premise to the user, and there are applications deployed to those servers. And we have to or want to make the user be able to discover those services. So for example, if there is currently some kind of a CDN in use to stream data from YouTube, then this is done by the CDN, and now we have to find a solution how we can discover these very near edge instances of our application. And our approach is to do that by pushing the service discovery closer to the user and don't leave it so much to the network, so to say. How do we do that? Actually, it is a very simple approach. We have a couple of design goals, and the primary design goal was to use DNS, and we want to be capable of going into a very fine granularity with this discovery approach. For example, here we have Austria, and we have our main application running somewhere in a data center somewhere in Vienna, and we want to give some, so to say, some additional edge instance for that service here in this federal state of Carinthia, and its capital, which would be Klagenfurt, which is with its own zip code, which is another level, so to say, of our granularity. And then the fourth level would be basically the detailed address, even with the number of the building, which would be our highest level of granularity. And we use this kind of hierarchical structure to address our application. So if we have our service, which can be normally addressed like this, then we can try to access an edge. If there is an edge here in this building, then we could try to access and address the edge with this kind of full qualified name. And we can, out of this, for example, we have kind of 4 levels what we can use to access the stages. And we have some kind of a reference implementation for that approach, which is some kind of a middleware solution. So the user first downloads some basic JavaScript code with the browser when he requests the website, and this website does retrieve the current GPS position of the device. Then we do something which is called the reverse geolocation lookup, which will give us the address information. So from the GPS coordinate, we map to the address in a normal human readable form. Then our system does calculate those 4 stages, which we just described. And then we are going to check which of those 4 stages is available, because not all of the time all 4 stages might be available. Maybe it's just until hierarchy level 2 that there is a data center available, and all of the other 2 final levels, they simply don't exist, so we don't have to try to access them. After we know which stage or level of this addresses we build up are valid, we can forward the user to the closest edge instance of the desired application. So that's the whole process, so to say. I also would like to briefly give you a bit of an overview how this reference implementation of us looks like. So basically here we are in this building, and we see here the marker. So using Google, we are reverse geocoding the address. That's the address here in the middle part. And we realize, okay, our validity stage is level 4. So we have an edge server, which is here inside of the building. So we can directly forward the user to this open speed test instance, which is then our kind of simulation product our resulting server. Yeah. We also, of course, did some analysis and see are there really some big benefits, and as to be expected, the closer the server it comes to the user, the better the performance overall is, and the performance in terms of upload and download, the throughput was in general better. That's a thing, and also the latency. So we did a ping there, and the latency to the edge instance, which was quite in the proximity of the actual building where we have been in, was much lower than the latency to the standard server, which is somewhere in Vienna
I'm really
in the
sorry for
cloud.
disturbing you. I'm sorry for disturbing you, but we still have 2 minutes. If you want to
Yeah,
conclude.
I will hurry up. Yeah, I will skip the critical analysis, and I want to discuss a bit briefly about further work. So in our first stage, we did focus on this natural topology of things, so the address, so to say, but we also want to be capable of customizing those stages and the areas we want to use to resolve on. That's why we introduce geofencing as well. So we allow the user to discover different services depending if they are in the geozone red, or if they're in the geozone blue, or if they're outside of those geofences at all. So we can really very customizable, so to say, redirect users to a certain instance of our client application. What are the next steps, what we are looking for? Well, currently we are trying to speed the process up. As you can imagine, this middleware approach that we try to find the best server does take a bit of a time, and we try to improve on that. The second thing we want to touch is that you directly want to go for a browser plugin. So we would mitigate this step that we have to download some additional code before we have to go to the service we really want to consume. And the third thing we want to also discuss is how can we
Well, I think you have been muted. I can.
Sorry, we lost your voice. We can't hear you.
We can't hear you. Yeah.
For the last minute, yeah, we can't hear you.
No, we can't hear you.
Yeah.
Something might have interrupted your microphone, maybe. Yeah, we can't hear you. You are muted. It shows you are muted. Can you talk now, please? Yeah, we can hear you now.
I couldn't hear you. I'm sorry.
Yeah. We can hear
now,
you
now
now.
it's working. Yeah, now it's
No, it's working.
Go ahead.
Okay.
Yeah.
Other questions?
Yeah, the last slide was remaining. Yes, please go ahead. Yeah.
That was the last slide already.
Okay. So thank you very much for presenting the very interesting work. Well, this is something which has some potential applications, I agree. And within that particular regard, I have a curiosity. It's not a question. So do you think that, well, this DNS lookup system can also be extended to other IoT devices?
Yeah, we are looking into that, and we are just wondering a bit how to get it into the natural technology stack there. We are thinking a bit about doing a library so that the user can query the code, can query the endpoint, and then is getting this mediation source code in between. So that's what we are looking in. Also, if we are looking forward to this topic with geofences, then it changes a bit the execution time is getting bigger, and especially for IoT, this is getting more crucial. Yeah.
Absolutely. That is where actually, well, because I also work at the edge of edge computing and making real-time processing of data. Yeah. So well, it would be really interesting to have a separate discussion let's say, out of this particular meeting. So if you
I would
would
love.
be interested to extend the discussion, please drop me an email. I had shared the email before, and then we can fix a meeting and discuss further about it. Thank you.
I would love that. I'm coming back to you. Thank you.
Thank you. Thank you. If there is no other questions, I would like to request Fairoz to move to the next one, please.
Yeah, for sure. Thank you. Kurt, it was a good presentation. All the best, and thank you for being with us since yesterday continuously. It's highly appreciated. So now we are going forward to the next presentation with Mr. Baldur in presenting the paper Perceived Readiness of Information and Communication Technology Policy in Supporting Mobile Learning in Times of COVID-19 at South African Schools. All the best, sir. In your presentation, we are all with you.
Okay, thank you.
Could you be just
I'm trying to do, yes, I'm trying to share my screen here.
Sure, take your time.
Okay, good afternoon, colleagues. My presentation is on perceived readiness of ICT policies in supporting mobile learning in times of COVID at South African schools. Our approach in this paper is more of information systems than hardcore computer science, as has been presented by many of the presenters in this conference. So this study investigated how teachers perceived the readiness of policies in supporting the provision of remote learning as a strategy for mitigating COVID-19 disruptions. Due to COVID-19, several interventions were put in place by the World Health Organization and many governments across the world to protect the citizens. One of the interventions which was put in place was to close schools, universities, or learning institutions, amongst many other entities of the government which were closed. So the closure of schools, especially during the early days of COVID, almost collapsed the education systems, and it brought a lot of anxiety amongst the learners, the teachers, the governments, to such an extent that our government did not know what to do. They panicked. It was a serious problem. So during the early days, some schools realized that technological interventions were the only solution to such disturbances. Otherwise, because of the unpredictability of coronavirus, it attacks in waves. And I think we have all realized that now, that it attacks after a certain time, things get a little bit normal, it attacks again, and so on and so on. Every time it attacks, the schools were being closed. So turning to technological interventions were the only thing which could help. So during those early days, we saw that there were few schools which partially adopted technological intervention. Now the question will be why few schools try to adapt technological interventions to providing learning in terms of COVID. We see that here we are in a developing country, or you call them third world countries. We have got some technological environmental issues which we face, which affect learning in general. For example, we saw that schools could not go fully online because they were not ready. They did not have content created for online learning. Most learners in our country were not used to online learning. They have never been exposed to that before. Teachers did not have experience to teach online. And then we also have issues of computing devices. In most circumstances, you'll see that some families have got one computer which is shared by all the members of family, some they don't have. But the most available device which all families do have is a mobile device, whether a telephone or a tablet. So because of the availability of mobile devices, the most technology which is used in learning is mobile learning, because it is the one which is available. But at the same time, we also see that online learning is a challenge because broadband is quite expensive here in third world countries. Because of that, it is a challenge to fully go online. But also some prior studies have found that State Carriage in South Africa found that school ICT policies are outdated and do not recognize mobile technologies as tools for learning. As such, the policies fail to encourage, allocate resources, support, or force the schools to implement mobile learning. So these are some of the challenges. Okay. Okay, next. Okay, my computer was a little bit sticking. Okay, now to evaluate how the teachers perceive the school policies in supporting mobile learning, we employed the UNESCO policy guideline on mobile learning. The UNESCO policy guideline on mobile learning has got 10 components, but in this case, we only chose 6, which we thought were applicable to our situation. That is, we needed to check, to evaluate if the school policies were updated, were up to date, and talks to the current technological developments. We wanted to see if the school policies support teacher training. We wanted to see if the policies support the creation and provision of mobile content, if they promoted equal access. That means all the kids are supposed to have some mobile equipment which they have. So does it promote that? Promote cyber safety when learning online? And does it promote the use of mobile phones as a communication tool in learning? So this was the evaluation framework which we adopted from UNESCO. The methodology, this was a qualitative study which collected data through interviews. So we collected data from 10 schools. We collected data from 10 participants from 5 schools, and all the schools were private schools in Centurion, Pretoria, here in South Africa. We chose private schools because they were the first schools to adopt online learning during early days of COVID-19. And we saw that most government schools, the schools were totally shut down, and the learners were not even learning. And we analyzed data using Brown and Clark 2013's deductive thematic analysis. And as I've said, UNESCO policy guideline was used as an evaluation framework. The findings. Okay. We said that we wanted to find out if the policies were up to date. So we report on the status of the policies in the 5 schools. We found that in general, 3 schools had an ICT policy, while these 2 schools did not have ICT policies at all. But even though these schools had ICT policies, we saw that none of the schools had an M-learning policy or a policy that was specifically developed to support mobile learning. So even though there were no policies, we found out that from the teachers that the schools allowed the learners to use mobile devices at the schools. But in order for them to use the mobile device, they kind of controlled them using, to regulate them using code of conduct. These are like ethical kind of policies, like regulations that when you bring your mobile phone, you're not supposed to use it during class, you're not supposed to take pictures, you're not supposed to do this and that. So most of these regulations were like obstructing any use of those mobile devices in learning. And we also saw that some of the schools actually banned the use of mobile devices at schools on the religious grounds. They said that the learners were not even allowed to bring any mobile phone to schools because of their religious beliefs. We also checked on if the school policies supported the training of teachers, train and support teachers with respect to mobile devices. We saw that with respect to training, all the schools supported professional development of teachers. And the policies were not specifically mentioning mobile learning. They talk in terms of technology. This is kind of the nature of policies. Sometimes they are general. They allow other new technologies to be integrated. So we see that the teachers were supported with the ICT refresher courses, supported on new technologies, for example, Google Classroom, MS Teams, and so on, and other e-learning management systems. They were given training on that. And we saw that there were different modes of training which were provided, which were supported, like online training, seminars, technology champions. That means they will hire somebody who have got knowledge of the technology, then they come and they train other teachers. We also checked if the policies supported the creation and the provision of mobile content. Our analysis found that the policies were silent on the creation of mobile learning content. So even though the policies were silent, the teachers were not provided with any special software or hardware for creating mobile learning content. For those teachers who said they were eager to create any content which was accessible through mobile devices like quizzes and so on, they had to download some software, open source software on their own and try to give the interventions on their own without actually the support of the school, of the policies. But since the teachers generally use computers to prepare their lessons, like the Google platform, Google Classroom, and so on, the teachers perceive the content that they create as accessible through mobile phones, because most of these platforms, now they are developed to give access to mobile devices. So we realized that this is a situation where there is no special skill which might be required to create content for mobile access. And in terms of equal access, this is equal access. We are talking about that all the learners should have access to learning. Like if we are to go mobile learning, it's not supposed to segregate against those ones who do not have devices. Of course, we understand that in our environment, there are some families who do not afford to buy computing devices. So we also find that the policies were silent on the provision of equal access to learning through mobile technologies or any other technology. But even though the policies were quiet on that, some initiatives were in place to make sure that if...
I'm sorry for interrupting you, but we have 2 minutes more. Thank you.
Okay, thank you. So there were initiatives which were in place, like using the BYOD to solicit learners to bring their own devices, to make sure that the content which they create is uploaded on learning management systems that were accessible on mobile devices. Some schools had Wi-Fi, which they provided to students for free. And equal access, the teachers told us that equal access was challenged by that some of the parents did not have the necessary skills to help the students learning on mobile devices or any computing technologies, because they will struggle with things like setting up computers or configuring software and so on and so on. So we also see that there was an issue of safety, which we tried to find out, like how does the policy support the safety of use of mobile technologies? We found that all the policies were perceived to support the safety of learners, but the rules were so strict to such an extent that...
Yeah, I'm sorry, Doctor, for interrupting you back, but we have to finish because we are already 15 minutes behind schedule. I'm sorry.
Okay, thank you very much. So the policies were seen as obstructing the use of mobile technologies in learning. Okay, in conclusion, we deducted that the teachers perceived the policies as not supporting them because it did not support content creation. It has no equal access support, no support for parents or guardians, for parents as guardians of learners. Like we see that when we give online learning to learners, the parents, we assume that they've got knowledge of helping the learners, but in actual fact, the parents need some help. So this tells us that policies need to look into things like supporting the parents, or people need to come up with systems which can be used to support parents for online learning. Thank you very much.
Thank you very much for presenting this work. I think that while policy is something which is really needed, taking into consideration all the difficulties that are being faced in a number of different countries worldwide during this pandemic. We are glad that now we are getting out of the pandemic, but while this pandemic has taught us that there are situations which needs to be taken into consideration when anything as such is going to happen. So thank you very much for bringing it to our notice. So if there are no questions from the audience in the meanwhile, may we move to the next presentation, please?
Okay, thank you for the presentation. Now we are moving to the last part of the session. Yeah, it's over to you, sir. You can go ahead with your presentation. Thank you.
I'm audible? Okay. Good afternoon, everyone. This is Venkat from Britspilani, Hyderabad campus, India. Today, I'm going to present the applications of random forest. Application of random forest in the prediction of river water quality. So I did this work under the.
Hello, I saw you try to call me several times.
Sorry. Shall I continue?
No, please go ahead. Yeah, I think that there was.
Yeah, sorry, but the
something
slides
was
are not
mistake.
moving. Yeah.
Okay.
Yeah.
So I did this work under the guidance of Professor Jagadish Sharmala.
I believe you're a student.
One second.
Can you please mute the other participants, Fairuz?
The outline of the presentation is first we discuss about the background of the research, then we'll move on to study area and data collection, then the methodology that I followed for in this work, then we'll discuss about the results and conclusion. So background, coming to the background, water is a vital source of for all the human beings that are living on the earth, and also aquatic the species that are living in the aquatic biome. So this water has been contaminated due to various sources, due to various non-pond sources and pond sources. Non-pond sources such as runoff that are coming from croplands, as shown in this figure, croplands, rural homes, city streets, and suburban development. They are directly coming into these runoffs coming into the rivers or streams, which are contaminating. Also, few point sources such as wastewater treatment plants and factories, animal feedlot, and some other treatment plants. They are directly discharging this waste into the streams, so that these streams are contaminating. This is not the good sign for people and also the species which are living in the water. So, in order to avoid this, we need to predict the parameters which are contaminating in the rivers and streams. So for that, we require a water quality model. So the purpose of water quality model is for maintaining the water quality of the streams or river by predicting the particular parameters that are contaminating, that are creating problems. We can maintain the water quality in the streams. So by notifying the authorities, so that they can take necessary actions to reduce the contamination. Also, these mathematical models can provide a technical support to the researchers and engineers who are working in the field of water quality of the rivers and streams. So this is the purpose of water quality needs model. And coming to our study area, for this research work, we have taken Upper Green River watershed in the Kentucky State, United States of America. This map shows the various sampling locations of the Upper Green River watershed. These red points are indicating the sampling locations where we collected samples are being collected from these points. There are total number 42 points are there in this Upper Green River watershed. And this is the schematics of the stream network where the Green River is flowing east to west. The flow direction you can see the Green River is flowing from east to west. This is a schematic representative of the river. And these are the few characteristics and attributes of the Upper Green River, where the minimum elevation of the rivershed is 123.14 meter and maximum elevation is 497. And minimum maximum temperatures are ranging from 10.3 degrees to 28.9 degrees, and the mean annual precipitation also varies from 101441 to 1346 mm. And these are the latitude and longitudes of the sampling location stations. These are the details of this few details of the hydrology Upper Green River watershed. Coming to data collection, Water samples were collected in test tubes from 42 different sampling sites for a duration of 6 months. That is May 2002 to October 2002. Then they tested in the laboratory to find out the different quantities of the various variables. Then the precipitation and temperature data that has been taken from the Kentucky Climate Center. And with the help of RGS software and ArcScience square root transformation, we developed a new novel technology called land use factors, which these are also used for the prediction of the various variables. So out of these all parameters, for my work, I have taken causal variables, 5 causal variables, that is temperature, precipitation, urban land use factor, agricultural land use factor, and forest land use factor, and one effect variable, that is fecal coliform. So with these parameters, with these variables, I have developed a model with for random forest and ANN. So random forest, I will give you a brief information about the random forest. It was suggested by Breman in 2001. It is one of the accurate regressor and classifier with the inherent randomness. These trees are produced randomly by selecting all instances from training set and with restoration from original data. And this results equivalent to bagging and boosting, so that there is no alteration with the training set. And this is this model employs a bragging method that with ensembling learning representative. And one more advantage of with this random forest method is that we can find out the feature importance, like after of all the given inputs, what are the important features that are affecting the predictions. So with help of this default scikit-learn feature importance and permutation feature importance and drop column feature importance, we can also predict the important features of all the given inputs. So this also will be helpful in the prediction of the water quality of rivers. So coming to methodology, first the data set has been loaded in the Google Drive. We have developed this with Google Collaboratory in Jupyter environment. So the data has been loaded, and then data set has been divided into training, 70% for training, 30% for testing. Then we predict the fecal coliform from all the 5 inputs, that is temperature, precipitation, and 3 land use factors. Then the performance of the model was evaluated by computing the R-square values. The R-square values and RMS root mean square value also we computed, and arithmetic mean error also we computed. With help of these 3 parameters, we evaluated the performance of the developed random forest model. So for this this figure shows the results of the random forest models. Also for this, we have taken different number of sizes, like we have taken different groups. So first I have given all the inputs all together, and we predicted the fecal coliform. Then I taken individually one time precipitation and fecal coliform. One time I given temperature, then I predicted fecal coliform. One time I given urban land use factor, then I predicted fecal coliform. So like that, I have tried different combinations. So one versus one and 2 versus 1. Like once I've taken precipitation temperature, then I predicted fecal coliform. So like that, once I drop.
For interrupting you, but we have 2 minutes more to go. Thank you.
So okay. So like that, I've tried different combinations, and so this one also showing the same other combinations in this one. So if you look at these results, we can see when I given all the inputs, that is all the 5 inputs, temperature, precipitation, the results overall R-square value is getting better. Also when I used only precipitation temperature, this also somewhat better. And when I used only precipitation along with the land use factors, or when I use only temperature along with the land use factor, the results are getting better. So that means temperature and precipitation are some of the key parameters for the predicting of the water quality parameter. But also land use factor alone can't predict the water quality parameter effectively, but those also important. We can conclude that from these results. Again, I developed a neural network model using feed-forward back propagation network. These are the few parameter features that I have taken. So training algorithm has Lavenberg magnet and learning functions gradient descent and transfer function hyperbolic with 1 hidden layer and 11 hidden layers. I developed the feed-forward back propagation network. Then the results, when I compared the results with overall R-square of random forest and ANN, it has been the random forest results are better when I given all inputs. So I can say that random forest yielding better results when compared to ANN model. These are the few figures of the random forest R-square values. So these are the best figures for training and testing.
Sorry, last 30 seconds to conclude.
Yes, ma'am, completed. So these are the random forest for R-square value for ANN. So then I said I did default feature importance. So from this feature importance also we can see that precipitation temperature are the important parameters for predicting the water quality of the streams. But this is also important. From the results and from all the results we can conclude that fecal coliform can be predicted with lower RMS and AME values from temperature, precipitation, and land use factor using RF compared to feed-forward network. So RF random forest model is better compared to ANN model for this given data. And also, as I said, land use factors alone not giving better results, but with the help of this temperature and precipitation, the better results are better. So we can say that land use factors are important, very important in the understanding of water quality of the rivers. So these are few references. Thank you all for listening and for your time.
Yeah,
Any
thank you very
questions?
much for your nice presentation. I think that this is a classical problem of machine learning and mathematical modeling, and well, you have applied random forest, which is good because well then we can have some explainability also incorporated in this particular process. We can really understand that why those specific values are being chosen and why those particular features are chosen for this particular problem. So thank you very much. So, as such, I do not have any questions. I think that the results are thorough. I just have one recommendation is that because well you need to compare it with some other results, I would suggest that if you could select some more explainable AI-based approaches, okay, for comparing the results would probably be more relevant within this particular context. Yeah.
Thank you. Okay.
Okay. So if there are no more questions from the audience, so I would like to thank you all for your contribution to this particular session. We had very vibrant presentations, very important presentations, and all the authors, they have presented it very nicely. We started with some discussion on recommender systems, which then followed by the prediction or incorporation of finding some solution in supporting elderly people in their familiar surroundings. And then we seen pain detection using deep convolutional neural network from facial expression and motion. And then another interesting work was actually the mobile edge computing based localization using DNS. And then, well, we had one policy paper on the COVID-19 and the readiness of the ICT policies in South African schools, which is something very important given that well, for the future, preparedness for the future is needed if anything as such happens as well. And last but not the least, we had a random forest-based model in predicting river water quality, which is also very important for many future applications. So thank you all for the contribution to this particular session. I really appreciate your hard work and making the ICICT 2022 a successful event. And of course, I thank Fairoz for moderating the event. and you have been fantastic. So thank you very much. With this, I would like to close the session, and I wish that you enjoy the rest of the conference. Thank you very much.
Thank you also, Doctor, for your participation and for valuable notes. Thank you. Bye bye.